Hello and welcome back to the channel. So this is going to be part 2 of storage management. And in this video, what we're going to do, we are going to create an LVM. Let's take a look at our server just to refresh your memory. And if we take a look at the disk partitioner, we will see that we have the original partition of 8 GB here and the additional disk that was added that is not partitioned. And these volume groups were created when the machine or the VM was built. So now we are going to go through the process of partitioning the second disk. So clear my screen. To partition a new disk, we use the disk partitioner command with the CU arguments, and we list the drive we want to partition. If you type M, that's the command, you will see a list of commands you can use while we're in here. So just keep that in mind. So we're going to do N for new, P for partition. It's going to be the first partition. So how we're going to partition this drive is we are going to issue 1 GB for a Linux partition, 1 GB for a swap partition, and 7 GB for an LVM. So for the first sector, we leave it blank. The second sector, we add our space. We can add our space by either using kilobytes, megabytes, or gigabytes. So plus 1024 M is 1 GB. Then we hit the letter T, which changes the partition system ID. So the hex codes is how you actually issue the partition that you want to use. So by default, it issues a Linux partition, but we're just going to take a look at the hex codes. So a Linux partition is number 83. So if we did not go through the process of hitting the letter T, which brings up the partition table, it would have issued a Linux partition by default. We are going to use the hex code 83, and then we're going to issue the second partition. It's going to be primary, partition number 2. The first sector is blank, plus 1 gig. Then we list the partition table again with T. The first time the partition number didn't have to be selected because there was only one partition. So we're going to work on number 2. We still have the hex codes visible, and swap is 82, which is listed right here. Linux swap 82. So we just type 82 and enter. And if you ever want to check your work, use the M for help command. There's a print the partition table right here. So if you hit P, we'll see that we have dev SDB1, dev SDB2, Linux, and Linux swap. So then we're going to add the last partition with N. It's another primary partition. This one's number 3. The first sector is blank, plus 7G. Then T to issue the partition ID for number 3. And if you want to see the codes, you hit L, and 8E, which is right here, is a Linux LVM. So that's the code we're going to issue, 8E. And take a look. So now we have 3 partitions: Linux, swap, and LVM. Once we complete partitioning the disk, we will then hit W to write those changes to the disk. And it brings us back to the command line. So let's clear the screen. And then we're going to issue the command part probe, which issues the changes of these new partitions to the operating system. The command part probe and the new drive that we just partitioned, dev SDB. So now we move on to formatting the disk. In the previous video, we mentioned lsblk with the F argument shows us the formatting of the file system. We see that FS type, or the file type for this system, is exe4, and we are also going to format the new drive to be exe4. So we have dev SDB 1, 2, and 3. So to begin formatting, the command to format the partition is mk make file system dot the file system that we're going to use, which is going to be ext4. And we are going to start with dev SDB1. Okay, so that is formatted. And we are going to format the swap also. So we're going to make mk swap, and you issue the partition that is the swap partition, which is dev SDB SDB2. And we do not issue a formatting command for the logical volume manager partition. So if we run the lsblk command, we are going to see that dev-sdb1 is now formatted as ext4, and dev-sdb2 is formatted as a swap. So now that we formatted dev-sdb1 and dev-sdb2, we are going to mount dev-sdb1 to a directory. To mount a partition to a directory, first we have to create a directory. So let me clear the screen. And in this case, we are going to call the directory storage. So let's make a directory, mkdir. Yep, mkdir. Root file system storage. Now that the directory is created, we are going to mount the directory to the partition. And that command is going to be mount dev-sdb1 to storage. And if we run the mount command by itself, we're going to see that dev-sdb is mounted on storage as ext4 and is read and writable. So next we are going to make the swap persistent, and we make that with the swap on command, swap on with the a argument, which is, and then we issue the partition, which is dev-sdb2. So before we go into creating a logical volume manager, we are going to make these two partitions, dev-sdb1 and 2, persistent upon reboot by adding the UUIDs to the etc fs tab. So let me clear my screen. First, let's grab the UUIDs. So to see the UUIDs of the partitions, the command is going to be block ID, blk ID, and it lists all of the UUIDs of all of our partitions. So we are focusing on dev-sdb1 and 2. So I'm just going to copy number 1, dev-sdb1 is copied. Then I'm going to go into the fs tab file, and we see that within the fs tab file, we have SDA partitions already mounted in here. So we just go down to the end of the file, and we are going to append a UUID to the end of the file. So we start off with UUID equals, we go paste the UUID we just copied, space, and it is mounted on the storage directory. And I like to keep things kind of evenly formatted. It is an ext4 file system. So that is what goes here. Then we type defaults. Then we do 1 space 1. And then we're going to save this file. Then we're going to copy the UUID for dev-sdb2. Now this copy, we go back into the etc tab. So there are other ways we could have done that, right? We could have echoed. Well, let me show you another way of doing the same thing. So we can echo with 2 appends to the etc fs tab. And what that will do is add that line to the bottom of the file, and we will just type the information around it. So then when we go back into the etc fs tab, you'll see it there. Delete this line. And for the swap, this is our UUID. So I insert, just type in UUID equals, then we want to go all the way to the end of this line, and we make it's a swap. So the file system is a swap, which is also defaults, and that gets 0 space 0, enter, right quit. And one command we can check to make sure that our fs tab doesn't have any errors with anything that was mounted. You can run the mount flag a command. Since nothing returned, everything is fine. So let's just go move to the root file system. And if we take a look here, you'll see the storage directories here. It's 1 gig. And we can go into the storage directory, and we can use this like any other directory. I'm going to stop the video here. In the next video, I'm going to go through the process of creating the logical volume manager. If you like the information that we're sharing here on this channel, please hit the thumbs up button. If you have any questions about what was covered in this video, you can leave a comment or question down below in the comment section. And if you like the content that this channel is providing, please consider subscribing to the channel. Thanks for watching, and I'll see you in the next video.